Hi everyone, this video is going to talk about slope. Okay, so we're continuing to talk about linear functions, and one of the big parts of a linear function, whether it's a graph, an equation, just ordered pairs, whatever it is, slope is one of those really important things that we typically talk about when we're talking about linear functions. So slope is really just a rate of change. It's comparing the change in the y values, okay, which is our independent variable, or I'm sorry, our dependent variable, to the amount of change in our independent variable, which is x. So you can see that I have that formatted here in this little formula. Okay, so we're mostly going to think about it as the change in y divided by the change in x, but remember, dependent variable is referring to y, independent is referring to x here. So let's start off with kind of like a word problem here. Now, I have this table, and this table shows the balance of a bank account on different days during a month. What we want to do is we want to find the rate of change for each of the time intervals listed down below. Okay. So let's start off by just identifying what is our dependent, what is our independent variable, because we know that the rate of change or the slope is going to be the change in y divided by the change of x, but if you look at our table, it's labeled days in balance, okay? Now, remember my hints. Anytime you have time as a variable, it's like 99% of the time going to be your independent or your x variable, and then our balance would be y, the dependent, because if you think about it, the amount of money, in this case, that you have in your bank account depends on the day of the month. Okay, it depends on if you've got paid, if you spent money, and that really comes down to the days. So we're just going to label that off to the side. Our dependent variable is the balance. Okay, and remember, balance is just how much money you have in your bank account. And then independent would be the day number. So you can see that I already worked out the rate of change between days 1 and 6. So we have the change in the balance over the change in the days. So my calculation came from this. I looked at my table. I took the change in y, the change in the balance. I did 285 minus 550. I did that by the change in days, or x, which was 6 minus 1. I simplified and I got negative 53. Now, within the context of this problem, negative 53 means that we are losing $53 per day between days 1 and day 6. Okay, so we're losing money, which makes sense because on day 1 we start with $550. By day 6 we're down to $285. So we're losing money, specifically $53 per day. So let's do the same thing for day 6 to day 16. So we're looking at some new points here. Okay, now the information that I care about is right here. So if we want to find the rate of change, we're going to take the difference in the y values, 210 minus 285, and we're going to divide that by the change in x values, which would be 16 minus 6. And notice I'm always taking the furthest right point and then subtracting the point to the left of it. Okay, and now we're just simplifying. So this ends up giving us negative 75 over 10, which would simplify to negative 7.5. And then, again, this means dollars per day. So between days 6 and 16, we're losing a lot less money per day. We went from spending $53 per day to only $7.50. Okay, so let's go to day 16 to day 22. Okay, so again, we're going to do the difference in our y values, so 210 minus 210 divided by the difference in the days, so 22 minus 16. Now here we get 0 over 6, which is just 0. So that means we are spending $0, or not days per dollars, $0 per day. And that makes sense because if you look at our table, on day 16 we had $210, and on day 22 we still had $210. So we're not spending any money between those days. Okay, lastly, we're going to do day 22 to day 30. So again, difference in the y values, 175 minus 210, divided by the difference in the days, 30 minus 22. Okay, and when we simplify, we get negative 35 over 8, which we'll have to do a little bit of rounding here. Let's go ahead and make it negative 4.38, so $4.38. And that's how much we're spending per day between day 22 and 30. So now we want to look back and we want to figure out where was the greatest rate of change. When were we spending the most money per day? Okay, and that takes us back to day 1 to 6. Day 1 to 6, we were spending the most per day, giving us our greatest rate of change. So this is just one example of what rate of change is. When we're talking about linear functions, we call our rate of change the slope. And when I have a line, the slope of the entire line, the slope between any 2 points found on that line, and remember there's an infinite number of them, the slope between any 2 points is the same. Now that's really convenient, okay, because if I can just pick 2 points on my graph and find the slope between them to find the slope of the line, that's pretty easy. So here's the way that we like to think about that. Remember, rate of change, or slope, is really the change in y over the change in x. And when we look at it graphically, a lot of times you'll see that referred to as the rise over the run. The rise refers to the change in the y. The run refers to the change in x. So let's look at some examples. Now, there's something that you have to be careful about here. Whenever we're doing this, I want you to always go left to right. So we're going to start at the left point and work over to the right point. So we need to do our change in y first. So we need to go up and then right to get to this point. Whenever we go up, that's a positive number, so we went up 3. We went right 1, 2, 3, 4, 5, 6. So our rise is 3, our run is 6. And we said the slope is equal to the rise over the run. Now, we use the variable m to represent slope. So we'll say m is equal to rise over run, which in this case gives us 3 over 6. And then we want to reduce this to 1/2. Now, here's something I want to show you. The slope between those points, okay, is 1/2, but we had to go up 3 and right 6. So let's do this. If we just start here again, and if we go up 1, right 2, we land out another point on the graph. If we start there and go up 1, right 2, we land at another point on the graph. Up 1, right 2, we land at that point. So the slope between any 2 points on this graph is 1/2. We can go up 1, right 2 to get to the next point. Now the next one, and this is where we really have to be careful about going left to right. This one, when we go to find our change in y, it requires us to go down. And anytime we go down, we have to use a negative number. So here we're going down 3, so our rise is negative 3. Okay, and then we went right 4, so the run is 4. Now we said slope is rise over run, so we're going to do slope, m, is equal to negative 3 over 4. And this does not reduce, so here's our slope. Now, in general, we have 4 different types of slopes, okay? And we're not working with numbers specifically here, but if you ever have a line that is rising as it goes from left to right, this is what we refer to as a positive slope. So just like the example that we saw, okay, when our slope was 1/2 here, okay, our line was going up as it moved from left to right. But for the second example, it was going down from left to right, giving us a negative slope. So that's all this is showing us here. As we go down from left to right, it gives us a negative slope. The 2 that are really special here are these ones, okay? Whenever we have a horizontal line, we have a slope of 0. Okay, it's flat. It's not going up any. So it gives us a slope of 0. An undefined slope is given by a vertical line. So if you had a horizontal line, you would do something like this. You would just say m equals 0. But for an undefined slope, okay, for a vertical line, you would actually write that the line has undefined slope. And the reason that this happens is if you tried to count your rise over your run, you end up with some number over 0. And you guys know that we can't have 0 in the denominator of a fraction. We can't divide by 0. So that's what makes the slope undefined. Now, sometimes we're not going to have a graph. We're not going to be able to just count up or down and then over some. Sometimes we're going to be given just 2 points, and we have to use the slope formula, which is this. M equals y2 minus y1 over x2 minus x1. Okay, and these y2 and y1s and all these things are subscripts. Okay, and they're just referring to the 2 ordered pairs that you started with. So the way I think about it is, this is my first ordered pair. That's what makes the subscripts 1. This is my second ordered pair. That's why the subscripts are 2. All you have to do is take the ordered pairs that are given to you, label them, and then substitute them into the formula. So we have m, the slope is equal to y2 minus y1 over x2 minus x1. Okay, so for this one, y2 is 2 minus y1, which is a negative 2, so be careful here, divided by x2, which is negative 1, minus x1, which is positive 4. And then we simplify. If I have 2 minus a negative 2, that's really 2 plus 2. Okay, negative 1 minus 4 gives me a negative 5. I end up with 4 over negative 5, but when we talk with slope, we want our negative to be in the numerator. So we're going to write it as negative 4/5 instead. So without looking at the graph, we were able to identify the slope between those 2 points that were given to us is negative 4/5. We would have to go down 4, right 5 to get to the next point on the line. Let's look at a couple other examples. Again, we're going to start by labeling. And then we substitute. So y2 minus y1 would be 3 minus 1. x2 minus x1 would be 4 minus 1. We get 2 over 3. So we would have to go up to right 3 to get from one point to the next on that line. Okay, and lastly down here, again, we'll start by labeling, substituting it into our formula. y2 minus y1 is negative 2 minus a negative 9. x2 minus x1 is 3 minus 5. And if I have negative 2 minus negative 9, that's really the same as negative 2 plus 9. 3 minus 5 gives me a negative 2 in the denominator. I add my numerator to get 7 over negative 2. And again, we want our negative to be in the numerator. So we're going to write this as negative 7/2. We would go down 7, right 2. All right, so that is it for this video. I hope it helped. If you need to rewind and rewatch, please do so, and have a great day.